Okay, so we're going to start chapter 2 today, and chapter 2 is all about summarizing data in tables and graphs. And I think that I have learned how to use PowerPoint on the iPad, so you'll be able to see all my transitions and all the answers won't be staring at you right away. I do have to switch between the pen, Apple Pen, and my finger. My finger is the one that's going to do the transitions, and the pen is what I'm going to need to write with. So bear with me as I try to figure that out. Okay. So 2.1 is about organizing qualitative data. Okay, again, that's descriptive data. So our objectives for today, we're going to organize qualitative data in tables, we're going to construct bar graphs, and we're going to construct pie charts. So you are going to need your protractor for this section. Okay, when data is collected from a survey or designed experiment, they must be organized into a manageable form. Data that is not organized is referred to as raw data. So there's 3 different ways that we're going to talk about organizing data. We're going to use tables and graphs, which that's what we're going to do today. And then in chapter 3, we're going to talk about how to do numerical summaries. And there's going to be all sorts of ways that we'll learn how to do that. So objective number 1, we want to organize qualitative data into tables. This you may have seen in algebra before as well. A frequency distribution lists each category of data and the number of occurrences for each category of data. Okay, for example, the data on the next slide represents the color of M&Ms in a bag of plain M&Ms. We want to construct a frequency distribution of the color of the plain M&Ms. Okay, so here is the list of all your colors. And again, I'm going to flip to the next slide. And what you can do, again, you'll hopefully be able to see the colors and then do on your paper the frequency table as I'm going to do it on the next slide. Okay, and here we go with the pen. All right. So I'm just going to read off the colors, and as I read them off, I'm going to just start doing tally marks. And to not bore you to death, I'm only going to do 1 row just so you get the feeling for it. Or actually, I'm going to do at least 1 till I get to 5. Okay, so the first one that I have is brown. Okay, and as I'm putting a tally mark, I'm going to cross off the color on the other slide just so that I know that I've used it already, and so you don't get bleary-eyed and hard to keep track of it. So you had brown for 1, then there's the second brown, then yellow, then red, another red, brown, orange, a blue, a green, okay, and so on and so forth. And what's going to happen in the end is that you are going to end up with 12 tallies for brown. And again, once you get to a 5th tally, remember you're crossing it off like that in groups of 5. So you're going to have 12 brown. You're going to have 10 yellow. Again, you should double check me, but just so you're not sitting here listening to me read off colors, because there's no point in doing that. There's 9 red. There's 6 orange. There are 3 blue. And there are, that is a, I don't know how to erase. That's apparently another thing I have to learn. Okay, so there are 3 blue and there are 5 green. So your frequency, you're just counting up the tally marks that you have. So I have 12, 10, 9, 6, 3, and 5. Okay, so what the relative frequency is it's the proportion or the percent of observations within a category, and it's found using the formula relative frequency, there should be an equal sign here, equals the frequency over the sum of all the frequencies. Okay, a relative frequency distribution lists each category of data with the relative frequency. Okay, so we're going to use the frequency distribution obtained from the prior example, so the one that we just did with our M&M colors, and we're going to construct a relative frequency distribution of the color of plain M&Ms. So again, that is the table that we just did. And now we're going to convert that to a relative frequency. So again, you're taking your frequencies and you're adding them all together down straight down this column. And when you add straight down, you should get an answer of 45. So to find the relative frequency, you're going to take your 12 and divide it by 45. I'm going to round to 4 spots after the decimal, I guess. So that'll give you 0.2667. The next one's going to be 10 divided by 45. And that will give you 0.222. Oh, no. There we go. I'm learning. You can't touch the right side of the screen. You touch the right side of the screen, it advances the slide. You touch the left side, it goes back. Haven't learned how to erase yet, though. So 9 divided by 45. And that will give you 0.2. The next one's going to be 6 divided by 45. So you're going to get 0.1333. 3 divided by 45, which is going to be 0.0677. And then finally, 5 divided by 45 will be 0.111. You should definitely always double check my math, especially because I'm trying to do 14 things at once here. Okay, so those are your relative frequencies. Okay. So now what we're going to do is we're going to construct a bar graph. So we're going to take that information that we just found and we're going to make a bar graph out of it. So a bar graph is constructed by labeling each category of data on either the horizontal or vertical axis and the frequency or relative frequency of the category on the other axis. Rectangles of equal width are drawn for each category, and the height of each rectangle represents the category's frequency or relative frequency. All right, so again, we're going to use that M&M data. We're going to construct a frequency bar graph first, and then we're going to construct a relative frequency bar graph. Okay, so again, we have our frequency table. This was for the first one, just a count of how many there were of each item. And when you do this, again, a little bit of pre-planning is always good. The highest frequency that you have when you look back is 12. So you just want to make sure that you go up by 12. And if you give a quick count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, I have enough room to make every bar worth 1. But instead of writing it, just so everything doesn't get smushed, I'm only going to write every other number. So that'll be 2, 4, 6, 8, 10, 12. I'm a creature of habit as well. I'm doing frequency along my y-axis. Again, a bar graph doesn't matter. A histogram does, but this is not a histogram. This is a bar graph. Okay, so I'm going to do my frequency on my y. Okay, and then going across the bottom, I have to make my bars for each of my different colors. And if I give a quick count of my colors, I had 1, 2, 3, 4, 5. I have 6 colors. So I think I'm going to have enough room to make each bar 2 units wide, and then skip a unit, and then next bar 2 units wide. So the first color was brown, and again, if you look back at that other table, brown had a frequency of 12. So I'm going to go up to 12. I'll draw a bar that is 12 units high. And just so you can see it a little bit better, I'll give it a quick little color right there. And that bar represents brown. The next color that we had was yellow. Yellow went up to 10. So again, I'm going to go up to 10. And I'll give that a quick color in. And that will be my yellow. Next color was red. Red went up to 9. Again, be consistent since I'm skipping 1 bar between every color that I'm drawing. Make sure that you continually skip the 1 bar. Don't skip 2 between the next one. And this one was red. Our next color was orange, and orange had 6. Again, skip a bar over. That's orange. And my next one was blue, and blue had a frequency of 3. And that's blue. And then lastly, we had green, and green had a frequency of 5. So there is your frequency histogram. Okay, and on the next slide, there is going to be a computer-generated one from Excel. So if you put all that information into Excel, Excel can make a bar graph for you, and that is what it would look like. And you can see it looks pretty much exactly the same as the one that we just did. So now there is our relative frequency table again that we just did a few slides ago. And now what we're going to do is we're going to make a relative frequency table. So it's going to look kind of the same as what we just did, except now instead of using this table for my y-axis, we're going to be using this table for the y-axis instead. So again, it just takes a little bit of pre-planning. And when it comes to the decimals, I like to think about decimals as money. It just makes it easier. And when you talk about money, dollars and cents, we talk about 2 spots after the decimal. So this is going to be like 27 cents, 22 cents, 20 cents, 13 cents, 7 cents, and 11 cents, just to give you an easier way to talk about it for the next slide. Okay, so here is my graph again, and again on the y side, I'm going to do my frequency, but again, this is relative frequency this time. So this is going to be my relative frequency, and on the bottom, again, I'll put my colors on the bottom. Okay, so going across the bottom, it looks like I have the same amount of bars going horizontally going across. So I'm going to do the same thing. I'm going to make each one of my bars 2 units wide, and I'm going to skip 1 bar between each of my colors. Going up my relative frequency, again, if you look back, the most money that you had on that last slide, let's see, I'm going to have to shut my pen off. The most money that you had on that last slide was 27 cents. So I need to go up to the highest value of 27 cents, and my lowest value here was 7 cents. So I think I'm going to count by 5 cents, because I think I'll go from, let's see if it'll work, 5, 10, 15, 20, 25, 30. Yep. So I'll get up to 30 cents that way. Again, it's just so easy to talk about decimals in terms of cents like that. So this first line right here is going to be worth 5 cents, 10 cents, 15 cents, 20 cents, 25 cents, and the last one is 30 cents. Okay, so brown, again, if you look back at your last slide, brown had a relative frequency of 0.2667. Okay, so that's like 27 cents. So 27 is a little bit more than 25. So I'm just going to go a little higher than 25. Again, am I going to know if you went to 25, 26, 20? I know if you go to 25 because it would be on the line. But am I going to know whether you're at 27 or 28? No. So you're just going to estimate it. It's higher than 25. It's lower than 30. And go over and then down. Okay, and that one, first one is going to be our brown bar. Okay, the next one was 22 cents for yellow. Again, 22 cents is somewhere between 20 and 25. So there is my yellow bar. And my next one is red, and red was 20 cents. That one's right on the money this time. And then for orange, we had 13 cents, which is higher than 10, but lower than 15. And then we had blue, which was 7 cents, a little bit more than 5, but less than 10. Would be nice if I knew how to change the colors on this in the PowerPoint so I can make the bars match the colors that I'm talking about. That'll be on my next one, I promise. And then 11 cents, a little bit more than 10, but obviously less than 15. And there is your last one, and that was green. Okay. So if you look back and you look now at this graph and the frequency graph, you can see that, except for the fact that we're talking about decimals here, but in terms of the bars and their relationship to each other, the pattern of the bars is pretty much exactly the same. Okay, so relative frequency and frequency, again, the only difference is with the relative frequency that you divided by the sum of the frequencies. And again, the next slide is just going to show you a bar graph that was generated in Excel for that. Okay, so there's your bar graph. And then on the next slide, what we're going to do, just before we go there, I just want you to look at this one for a second. This is exactly what we just drew. Okay, and then I'm going to say the next slide kind of while I'm on this so that you can be looking at this at the same time and then tell you what's going to happen on the slide after that. So the next thing that we're going to talk about is a Pareto chart. And a Pareto chart is a bar graph where the bars are drawn in decreasing order of frequency or relative frequency. So it could be for either one of your graphs. Okay, so notice on this one I have This is the highest, the next highest, the next highest, the next highest, and then all of a sudden these two would be out of order. So if you're going to make a Pareto chart, what you're going to do is you're going to reverse those two. So again, the next one would come now that I've switched it. I have no idea how I just did that because my pen is still on. So our Pareto chart is going to be a bar graph where the bars are drawn in decreasing order of frequency or relative frequency. Like I was just saying when I so rudely interrupted myself. Let's see if I can keep the pen on and see if I figured out now how to switch with the pen on. Of course I didn't. Oh, there we go. Look at that. Okay. And the problem with the one that is showing right now, I have no idea why. You're actually missing your blue bar. Your blue bar should be right over here. Okay. But that is your Pareto chart. Okay, so all it does again is go in, your bars have to go in decreasing order. And again, that can be for a frequency histogram or a relative frequency histogram. Okay. Not only can you use a bar graph for one set of data, you can also use a bar graph for two sets of data. And it's actually very helpful when you're using it with two sets of data because you can see the difference between each data set. See if I can figure out how to switch the color of the pen eventually. Okay, so if you're going to compare two data sets, the following data represents the marital status in millions of U.S. residents 18 years of age or older in 1990 and 2006. Draw a side-by-side relative frequency bar graph of the data. Okay, so we want a relative frequency bar graph here, not just a frequency. Okay, so the first thing that we're going to have to do before we can draw the relative frequency bar graph is find out what our relative frequencies are. So again, to find the relative frequency, you're taking the frequency and dividing it by the sum of the total frequencies. So the first thing I'm going to do is I'm going to add straight down the 1990 column and figure out what I get. When you do that, you should end up with an answer of 181.9. See if I can... No, it's not going to let me. I was trying to figure out with this little pen on top how to see if I could switch the color. Don't know how to switch the color still. All right, we'll get creative. Okay, and then for when I add straight down for 2006, the frequencies there, you should get an answer of 219.7. Okay, so to find your relative frequency, I'll write the first one out in each category, but it's going to get kind of messy. So I'll just write the first one out and I'll talk you through the other ones. So for this top one, we're going to do 40.4 divided by 181.9. Okay, and again, I'm going to go out to 4 spots. Kind of pretty much everything that we do in statistics for the rest of the year, we're always going to push that data out 4 spots. So this is going to come out to 0.2221. So the next one you're doing is 112.6. And again, you're dividing that by that same number, 181.9. And when you do that and round correctly, you should get an answer of 0.6190. Next one for your widowed, 13.8 divided by 181.9 should give you an answer of 0.0759 when rounded correctly. And then divorced for 1990, 15.1 divided by 181.9 should give you an answer of 0.0830. Okay, for your other one, for 2006, we are going to do 55.3. This time we're dividing by our total frequency there, which was 219.7. And when you do that, you're going to get an answer of 0.2517. So everything in this column is getting divided by that 219.7. So next one, 127.7 divided by 219.7 should give you an answer of 0.5812. 13.9 divided by 219.7 is going to give you an answer of 0.0633. And then the last one, 22.8 divided by that same number, you should get an answer when rounded correctly of 0.1038. So there are your relative frequencies. And again, now that we have the relative frequencies, we can go ahead and make our relative frequency chart graph. Okay. So again, creature of habit, I like my frequency, or in this case, my relative frequency on my Y side. So again, I'll call that relative frequency. And then across the bottom, that's going to be our marital status. Okay, and I'm going to make a key because I don't have, well, I don't know how, I should say. Not that I don't have. I probably do. I just don't know it. A key of what my bars are going to look like. So I'm going to make 1990 little colored in. And I'm going to make little dots in the one that's going to represent 2006. So you can tell the difference between the two. Okay, so again, if you look back at that relative frequency tables, again, think of everything in terms of dollars and cents. Okay, so it looks like if I look back, I'm looking back at mine, it looks like your highest value is 62 cents and your lowest value is 6 cents. So again, I have to go up to about 62 cents, so about 70 cents. Let's see if I count by 10 cents. So if I went 10, 20, 30, 40, 50, 60, 70. Yep. So if I count technically by 10 cents, again, I know we're not talking about dollars and cents here. It's just so much easier to think about it that way. 20 cents, 30 cents, 40 cents, 50 cents, 60 cents, and 70 cents. Okay, so we're going to talk about never married first. So we're going to talk about never married at the same time, 1990, 2006. So never married in 1990 was approximately 22 cents. I'm going to make that worth 1. And again, 1990 is the one that I'm going to color in with the lines here. So there's my bar for 1990. Right next to that, touching that, I'm going to draw another bar that's going to represent my data from 2006. So if you look back to 2006, that's about 25 cents. 25 cents is more than the 22 cents that we just drew. So my next graph is going to be a little bit higher. My next bar is going to be a little bit higher than the other one. And again, I'll put dots in there. It's really easy if you have 2 different colors. Okay, and again, those 2 bars represent my never married. The next bars are going to represent our married group, and our married group in 1990 was approximately 62 cents. So 62 cents is more than 60 cents, but less than 70. So there will be that one. And again, we're using the color in to represent 1990. And then in 2006, it went down to 58 cents. So 58 cents is a little less than 60. And we're putting dots in there to represent that one. And that was my married. And then we have our widowed. Widowed in 1990 was approximately 8 cents. So 8 cents is a little bit less than 10 cents. And again, we're coloring that one in with lines. And then in 2006, it's approximately 7 cents, which is less than 8 cents. So I'll just draw it a little bit underneath that. And then dots. And those are my widowed group. And then divorce. Divorce in 1990 was 8 cents. So again, less than 10. And in 2006, it's a little bit more. It's if you rounded it, it would be 10 cents. It's technically a little bit more than 10 cents because we're, again, dollars and cents. We're only talking about the 2 spots. So I'll just make it a little bit bigger. And that is your divorced group. And there is your side-by-side relative frequency graph. And again, if you put this information into Excel, that's what it would look like. And it's very nice when you can see the 2 different colors there. Okay, if you don't have 2 different colors, just like I did, just make yourself a key off on the side. They did a key too, even with the 2 different colors. All right, so objective 3 is to construct pie charts. This is our last objective, and this is the one that you need the protractor for. So I'm going to kind of talk you through, we'll figure out the math part of it first, and then I'm going to play another video that's going to kind of show you how to make that pie chart. And I'm going to ask you, part of your classwork is going to be to draw a pie chart. But I'm going to tell you right now, and be completely honest with you, I am not going to ever test you on drawing it. I'll test you about like the size of the angles and things of that nature, but I will not ask you to draw it, just because I don't think it's fair that asking me to watch a video, and some of you I'm never going to see in person, or I'll see you on the wrong day and won't be able to show you how to use that protractor in person. It's fairly straightforward. The video is easy, but again, in my heart of hearts, I have a hard time testing you on something that you are strictly learning from a video. Okay. So pie chart. A pie chart is a circle that's divided into sectors, and each sector represents a category of data. The area of each sector is proportional to the frequency of the category. Okay, so again, we're going to look at our same set of data here. We're going to talk about our marital status again from 2006 only, though, this time. Okay, so the following data represents the marital status in millions of U.S. residents 18 years of age or older in 2006, and we want to draw a pie chart of the data. So it's the same exact data that we just did. We're just going to do it in a different way. Okay, so the first thing that we're going to do is we are going to find out what our relative frequencies are. So again, you don't even have to find them out. We did them on the other slide. So I'm just going to copy them from the last slide that we did. So our relative frequency, again, this was 2006. So that was 0.2517, 0.5812, 0.0633, and 0.1038. So there's your table again. And now what we want to do is we want to figure out what the size of our central angles are going to be for that pie graph. So how are we going to do that? All you're going to do is take those numbers that we just wrote on that last slide and multiply it by 360. So next to never married was 0.2517. Literally all you're doing is multiplying that by 360. When you do that, you're going to get 90.612. So we'll approximate that and say that it's 91. Okay. Then married was 0.5812. You're going to multiply that by 360, and that should give you 209.232. So again, that'll be approximately 209. And then we have our widowed, and widowed is going to be 0.0633 times 360. And when you do that, you should get 22.788. So again, we'll call that approximately 23. And then our last one for divorced is going to be 0.1038 times 360. And that will give you an answer of 37.368. And we'll round that to 37. So these are going to be the measures of all your angles. And now we want to draw the chart that is going to go over that. So I'm going to now play a video that's going to bring you into YouTube. I'll play through that video. I'll come back one more time, and then you'll be done for the day. Just a thing here. When we were finding the measure of our central angles, the first thing that we found was the relative frequency. So we divided first by the frequency and then multiplied by 360. This guy in this video does the opposite thing. He's going to multiply first and then divide. It doesn't matter. That's not the